Yeah, welcome back everybody. We're back from a break and let's continue. Let's go straight to it. The next question is number 5, and that in the diagram below, LMN are points on a circle center O. Angle NMO is A and angle NLO is B. Angle NLO equals B. Find the obtuse angle MOL in terms of A and B. So let's copy the diagram very quickly. This is the diagram and then put it here. That's question, that's number 5. Now angle NMO, O is the center of the circle, angle NMO is A and angle NLO is B. Find the obtuse angle MOL. This is the obtuse angle MOL in terms of A and B. First of all, let me construct another radius ON, which is going to be the same as OL and OM. So that simply means this triangle is an isosceles triangle because ON and OL are radii. And what does that tell us? That simply means that this angle is also B. Base angles of an isosceles triangle are equal. This is also another isosceles triangle with radii ON and OM. ON is a radius, ON is a radius, and OM is also a radius. So that simply means these angles are equal, and this will also be angle A. This angle and this angle will be equal. So that means this is also A. The reason for that is base angles of an isosceles triangle. So that simply means the whole of this angle is A plus B. That's A plus B. So therefore, obtuse angle MOL is equal to 2 times angle MNL. Angle at center is twice angle at circumference, and that's 2 times A plus B. That's it, very very simply. That was a piece of cake. And let's go straight to the next, which is number 6. Number 6. Find the lettered angles in the following. Where a point O is given, it is the center of the circle. So let's copy the first question, the first diagram. This is the first diagram, and that's it. Now how do I find? Okay, I can see that angles A, this angle A40, angles A40 and B are in the same segment. If I divide the circle into 2 segments this way, this is one segment and this is another. So A, B and 40 are in the same segment, so that means they are equal. So A equals B, which also equals 40 degrees. So that means A is 40 degrees and B is also 40 degrees. Now to the next. If I construct a chord here, if I put a chord here, if I construct another chord here, I would see that angles 30 and C are in the same segment. I've told you we've learned the trick for that. Just check the 2 lines that form a triangle. Just check the 2 lines that form a triangle with that chord, and the angles between those 2 lines, those pair of lines, are going to be equal. 32 and C are the angles. So that means C is also equal to 32 degrees. Angles in the same segment. I go over that again. I can see that this line and this line form a triangle with this chord. So that means this angle and this line also form a triangle with this chord. So that means this angle and this angle, the angle formed by those pairs of lines, are going to be in the same segment. So this angle and this angle are equal, they are in the same segment. So now to the next very very quickly. And then Yeah. To the next, very quickly. I'm trying to make that. Yeah. To the next one very quickly. It says that's B, 6B, question B. Let me copy the diagram. This is the diagram. Yeah, that's the diagram. So first of all, angle E is 90 degrees, angle in a semicircle. How do you know that? It is the angle formed by any two sides that form a triangle with the diameter. This is diameter, and these two lengths form a triangle with the diameter. So the angle between these two lengths is 90 degrees. That's very simple and straightforward. So E equals 90 degrees, angle in a semicircle. Now if we look at this, let's look at this chord, this pink chord. Would see that this length and this length form a triangle with it, and this length and this length also form a triangle with that pink chord. So the angle between those pairs of lines are going, the angles between those pairs of lines are going to be equal. So that simply means D also equals, angle D also equals 115 degrees. That's it. That was a cheap one. And then we go to, I think I should leave the markings. Now we go to the next, which is C, question C. Let's copy the diagram. We are finding the sizes of the lettered angles. Now here, first of all, I can see that angle F is 90 degrees, angle in a semicircle. F equals 90 degrees. Of course, this length and this length form a triangle with the diameter of the circle. So the angle between them, which is F, is going to be a right angle. That's a trick for identifying an angle inside the semicircle. Now I already know that if F is 90, that means I can find G. G plus F plus 56, or if you like, F plus G plus 56 equals 180 degrees. Sum of angles in a triangle. So that simply means angle G is 180 minus the sum of F and 56. F is 90, and we add the two together to get 180 degrees. So let me put it this way: G F plus G plus 56 degrees equals 180 degrees, sum of angles in a triangle. And that means G plus, that means 90 plus G plus 56 equals 180. And that simply means G equals 180 minus 90 plus 50 is 146. And that means G equals 90 plus 56 rather. 90 plus 56 is 146 degrees. So that means G is 180 minus 146 degrees, which is 34 degrees. Now what's next? I want to find H now. How do I find H? If this line is parallel to this line, that means this angle and this angle are alternate angles. So it simply means that this angle is also the same as G, and that value is 34 degrees. Alternate angles. So if I know that this one is also 90 degrees, I shouldn't forget that that's the symbol for 90 degrees. This angle is also 90 degrees, angle in a semicircle. You can say that this line and this line, this length and this length and this length this length and this length form a triangle with the diameter of a circle. So the angle between them is going to be 90 degrees. So that's the reason for that is angle in a semicircle. So if this is 90 degrees and this is 34, then we can find H. H plus 90 plus 34 equals 180. H plus 90 degrees plus 34 degrees equals 180 degrees. Sum of angles in a triangle. That means H equals 180 minus 124. 90 plus 34 is 124. So H will be 180 minus 124, and that's 66 degrees. How about correct? 180 minus 124 is 56 degrees. 56 degrees. Now we have found FGH, and that's it, very, very simply. So we move to the next, which is question D. That's 6D. Let me copy the diagram. This is the diagram. Now we're finding the lettered angles rather. That's D. If O is the center of a circle, what's the first thing that comes to mind? If I construct a chord here, I can see that the circle will is now broken into two segments. This is one, and this is another. The yellow segment is the major segment, and the pink segment is the minor segment. So the angles in the same segment are equal. So all the angles in the angles in the major segment are going to be equal, and we know the trick for identifying the angles in the same segment. So I can see that this line and this line form a triangle with the pink chord, and this line also form a triangle with the pink chord. That simply means the angles between those pairs of lines are the same. So that means, first of all, that angle I is equal to 65 degrees. Those are the angles in the same segment. The reason is that they are angles in the same segment. Now what else? How do I find J? Oh, beautiful. That's simple. That's a piece of cake. Now I can see that the whole of this is 90 degrees. We can see that this line and this line form a triangle with the diameter of the circle. So the angle between those lines, the angle between this line and this line, is going to be a right angle, which is 90 degrees. So the whole of this is 90 degrees, and the reason for that is angle in a semicircle. So if you already know a part of it, which is I, to be 65 degrees, I plus J equals 90 degrees, angle in a semicircle. So that simply means 65 plus J equals 90, which means J equals 90 minus 65, and that's 25 degrees. So J is 25 degrees. So that's it, very, very simply. How about, was quite simple, straightforward, and brief. Thank you very much, and catch you in the next. Bye bye.